this is video number 2, as promised. So, I've been thinking about where I really wanted to take the channel, the target audience I'm really trying to reach. And, I figured that I can't really talk about tech and IT and, push that IT education if I don't start off with the basics first. I really want to get the IT terms down. I want to get the acronyms down. I want to get some common devices, names out there so you can be more familiar, so as the channel grows and as we get more into how-to videos or guides or just, general information, I want to make sure you know what you're talking about. All right, so here it is, common IT terminology. All right, so what is information technology? What is IT? So, IT is the use of any computer, storage, networking, and other physical devices, infrastructure, and processes to create, process, store, secure, exchange all forms of electronic data. So, in almost every business, whether it's a small business or a large business, or whether it's a school, you know, in this day and age, you will have an IT department, whether that's one or two people, 20 or 30 people, or a team of 100 people, whether they're local or whether they're, in another country and you're outsourcing that labor, you will have an IT team and they're responsible for systems, networks, data, and applications. So just a little bit about, the IT team's responsibilities is deploy and maintain business application services and infrastructure. So when I say infrastructure, I mean servers, networks, storage. They monitor, optimize, and troubleshoot performance of these application services and network devices. So, even if nothing's going wrong, they're always monitoring. And if something is wrong, then 9 times out of 10, you've probably sent a trouble ticket or, there's a help desk or you're yourself are trying to be at the help desk and you're answering those trouble tickets, so good luck. But you're troubleshooting the performance of those devices, processes, applications. And lastly, they will oversee the security and governance of the application services and infrastructure as well. So, as cybersecurity becomes more of a thing and a real concern in this day and age, you will have one or two people that is dedicated to governance or a whole team that is dedicated to governance. So, those are, the three areas where IT is going to be heavy the most and real active at the most. All right, so data. You will hear data so much in IT. In almost any industry, but in this industry for sure, you will hear data. So in computing, data is information that has been translated into a form that is efficient for movement and processing. Relative to today's computers and transmission media, data is information converted into binary digital form. So when I say binary digital form, I mean ones and zeros. To us, it looks like text, images, videos, pretty much anything. But in computers, network devices, it's really ones and zeros. Okay, so yeah, like I said, it's any set of characters that is gathered and translated for a particular purpose. If data is not put into a particular context, then data means nothing to humans or computers. Just additional types of data is single character, Boolean, number, floating points, picture, sounds, and video. Data passes through mediums such as switches, routers, and hubs. All right, so how does this data pass to these devices? How does it get from one place to another? All right, so you will either have a wireless network or you will have a wired network. And a wired network, you're going to use Ethernet and fiber cables most often. Oftentimes, it's going to be Ethernet, it's going to be fiber. Ethernet is usually used for small businesses, large businesses, homes, consumer devices, connect consumer devices, and long runs of cable. Fiber is a little bit more fast, high performance. The difference between the two is Ethernet is made up of copper. So it's a twisted pair of copper is what the Ethernet cable is made up of, and it uses electricity to transmit data. Fiber is a little bit different because it's made up of glass fiber core, and that core allows a beam of light to basically bounce up and down that cable and transmit information, essentially. All right, so what are these cables connecting to? Besides a laptop or server or client device, what is the next hop? What's the next step? What's the next destination? Here we have a Cisco switch. So Cisco is a big brand. You know, they have Juniper as well, and just different brands of switches. So a network switch connects devices in a network to each other and enables devices to talk to each other. You know, I can talk to, my PC here, and sales can talk to the PC up in admin because of a switch, probably. So it operates at layer two of the OSI model because it uses MAC address, and a MAC address is a physical address of a network device. It can operate at layer three, but that's a little bit more intelligent because at layer three, it uses IP addresses to route information. Here we are. So router. A router is a device that connects two or more packet switch networks or sub networks. So if you're new to IT or you have a Wi-Fi home setup, then you know what a router is. In businesses, it's a little bit more complex. They may be bigger, they may be more intelligent, they may have more ports, they may have different capabilities. But essentially, is a router will do the same thing no matter where, and what function and what capacity is used for. So the two functions is used to manage traffic between networks by forwarding data packets to their intended IP addresses and allowing multiple devices to use the same internet connection. It operates at layer three and is more intelligent because, like I said, it uses an IP address. So, what is an IP address? If you probably know what an IP address, like I said, if you have a Wi-Fi, a home network, you've probably seen an IP address. It probably starts off like something like 192.58.3.1. That's an IP address. Probably a gateway IP address, but it's an IP address. And IP addresses, you do have different classes. You do have public and private IP addresses. So, an IP address is a unique string of characters that identifies each computer using the internet protocol to communicate over a network. So, if I need to communicate to google.com, it looks like google.com, but that google.com translates into different IP addresses, or maybe one IP address, but probably different IP addresses. So you do have IPv4. That's the standard. That's what you're probably most familiar with. But as time is going along, and we're getting more technologically advanced. uh, you will probably come in contact with some devices that are capable of IPv6 as well, because IPv4 space address space is filling up or has filled up. So there are devices that are capable of IPv6, and probably will have an IPv6 address. All right, protocol port. So a port number is a way to identify a specific process to which an internet or another network message to be forwarded when it arrives at a server. All network connected devices come equipped with standardized ports that are assigned a number. So if I'm doing any type of processes, if I'm transferring files, if I'm trying to connect remotely to the server, or if I'm trying to secure shell into this Linux box here, I need to designate a specific port and protocol to be used to initiate whatever it is that I'm trying to do. So that's when you have a protocol and you have a port. For example, you probably know HTTP. That protocol is for accessing web addresses. So you have Hypertext Transfer Protocol, port 80. If you're accessing a secure site, the protocol will be HTTPS. So that client is reaching out to that server, and we're going to use HTTPS port 443 to get this process underway so I can access the website I'm trying to access. And you're acknowledging, well, that server is acknowledging that this is the protocol and this is the port that we're going to use. So we're basically on the same chord, and we can get this process done efficiently. So another protocol is RDP, FTPS, and SSH. So I mentioned client and server. When you're first getting started, you'll probably hear of client server model or client server architecture a lot. And that's just to really get the basics down of how a client device is communicating inside a network or outside a network, whether it's a web server or a domain server or web server, or any type of server, whatever function that that server is for. So a server is a sample of software or hardware that has a specific service to its clients. A client is a user program that connects to a server to access a service. A web browser such as Firefox is a client program that makes use of web service facilities. Like I said, you'll probably see this model or architecture, just a really simplistic way to get, that first, second, third hop down to establish that first path. And if you can really establish that first path or that first few hops, then you can kind of piece together more intelligent networks or more intricate networks. But this is just a really simplistic way of, looking at a client and a server and the purpose each one has. All right. Firewall. So you probably know what a firewall is. I keep bringing up home Wi-Fi networks because home Wi-Fi networks, may be smaller, have less capabilities, but essentially it's the best, I guess, similar setup that you may know to describe a more intricate or enterprise network. So, a firewall is a network security device that monitors and filters incoming and outgoing network traffic based on an organization's previously established security policies. At its most basic, a firewall is essentially a barrier between the internal private network and the public internet. For the last 25 years, firewalls have been the first line of defense in network security, and that is to protect internal and external threats. So firewalls can be hardware based and they can be software based as well. And just another gem, something maybe you can look up and see what I mean by this. You do have different types of firewall. You can have a stateless firewall or you can have a stateful firewall. So it's just something for you to look up and see what the difference is between the two and what those two firewalls do. All right, backup. So, backup is the process of creating a copy of the data on your system that you use for recovery in case your original data is lost or corrupted. You can also use a backup to recover copies of older files if you have deleted them from your system. So you're working, say you're at the help desk one day and you get a call and you say, "Hey, I just deleted this file." And you're like, another trouble ticket, but you have to help them. And you may need to access the backup server, or you may need to go to a local archival station, or just something of the sorts. But you can still access that file even if they did delete it, as long as you have a backup of that point in time where that file was on the network. You can still access that file and recover it for them. Or say, hey, you're working at the help desk one day, or you're a system administrator or domain administrator, and you're just looking at the network and you notice some slow performance on a virtual machine, and you realize that, hey, this virtual machine just received an update like 12 minutes ago, and as soon as it received the update, it's just acting horrible now. And everybody is running around like chickens with their heads cut off, and you're trying to figure out what to do. Um, you can probably put two and two together, and maybe one of your troubleshooting steps will be to roll back that update. You can roll back that update, or maybe you can't roll back the update. Maybe you'll have to go back to a previous snapshot of that virtual machine and restore it from there, and then get it back up and running to its most effective state. So you can roll back and that update, or you can go back to a previous snapshot of that virtual machine. But the concept that I'm trying to really explain here is that it's important to have backups. It's important to have different copies of data. So if anything goes wrong, and trust me, it will go wrong, you have a backup. You have two, three, four, five copies, maybe halfway across the world, maybe something secluded, but you do have a way to get that information back. All right, and those are the 10 terms. So I think I did a pretty good job of explaining those 10 terms and really breaking them down and just giving you the basics of IT. Trust me, it goes so much deeper. It gets very, very intricate, so much more vast. But I think with those terms right there, that's a good foundation. So when I'm talking about certain things, or if I bring something up, you'll have an understanding of what I'm talking about, or you can piece it together, or you can start to build your own foundation from these terms here. So like the screen says, subscribe for more. Video 3 coming soon, and I hope you enjoyed what I had prepared for you today. And yeah, if you stayed to the end, I definitely appreciate you. Remember to like and subscribe. But video 3 coming soon, and I'm out. Bye.